Why scale/open LLMs matter. Key benefits. Reduced vendor lock-in and cost control. Using an open source or open weights model gives a company more freedom to fine-tune, deploy on-premises or edge, choose hosting/infra suppliers, and avoid or reduce high recurring licensing/API costs. Customization and enterprise fit. You can tailor the model to your domain, industry-specific vocab, workflows, data, rather than be constrained by a black box API. This is especially relevant for business-specific use cases. Scalability and future-proofing. Scaling laws in ML show that larger models, given enough data and compute, tend to perform better on broader, more complex tasks, emergent capabilities, rather than only incremental gains. Competitive differentiation. If many companies use the same closed API, everyone's solutions converge. Having your own scaled/fine-tuned model can enable unique features or performance. Control of data, privacy, compliance. For certain regulated industries, finance, healthcare, etc., you may need to keep models and data in-house. Open models support that more readily. Innovation velocity. With open models, you can experiment rapidly, deploy bespoke pipelines, iterate without waiting on vendor feature rollouts. Specific to the Llama family/scaling. Llama and its ecosystem show that openish, or at least accessible, LLMs are already being deployed commercially and give significant value. The scaling up of Llama in parameter size, context window, etc. shows that companies can tap performance previously reserved for large cloud players. Why companies need it? Putting this into must-have rather than nice-to-have. If your business wants to embed generative/LLM capabilities, chatbots, assistants, content generation, domain-specific reasoning, and you don't want to be fully dependent on a third-party API, which may increase cost, limit customization, throttle usage, or expose you to risk, then building/scaling your own model, or using open weights plus fine-tuning, becomes practically necessary. If you expect your product to evolve rapidly, I, as AI consultant, believe AI changes every week. You'll value the ability to update/tune the model yourself rather than wait for vendor changes. For businesses targeting differentiation, not commoditized solutions, you need this scale to avoid being just another wrapper around a generic LLM. 2. Why metaverse-grade VR/AR AI rendering on low-power chips matters. The challenge and opportunity. For immersive XR/VR/AR, extended reality, experiences, especially those geared toward metaverse-style interactions, avatars, immersive digital twins, responsive environments, you need real-time AI or ML rendering, scene understanding, avatar behavior, etc. These experiences often happen at the edge, on a headset, mobile device, or at least with minimal latency, requiring efficient compute and low power consumption because of battery/thermal constraints. Low power chips, dedicated AI accelerators, optimized for inference from neural nets, graphics, ray tracing, enable these real-time experiences without needing huge data center compute. Why companies need it? If your business is creating VR/AR experiences for training, simulation, digital twins, retail/branding metaverse spaces, etc., you'll need the technology to support immersive experiences at scale and on devices, not just high-end PCs. Efficient rendering plus AI makes the difference between nice demo and deployable, widely usable product. If users need to plug into expensive gear and heavy compute, adoption will be limited. Low-power chips also hint at cost savings, less power, less cooling, smaller devices, which is important for productizing XR hardware or software experiences at enterprise scale. Control, just like with LLMs, having your own stack, including chip/firmware/AI inference, gives you control over performance, optimization, differentiation, and avoids being locked into other vendors' constrained hardware. 3. How the two relate and why doing both is strategically synergistic. Imagine a VR/AR application where you have A. An intelligent avatar/agent powered by a scalable LLM, e.g., you're using or fine-tuning Llama, and B. That avatar/agent is embedded in a metaverse-style virtual world rendered in real time on a low-power device. The model and the rendering hardware/stack must work together. By combining open model scaling plus efficient rendering slash hardware, you get a stack where you can own both AI and experience. AI logic, LLM, plus immersive UI slash UX, AR slash VR, plus edge devices that deliver it. This gives end-to-end control. Many businesses are just focusing on one side, either AI in a cloud or AR slash VR, but reliant on big compute. But for future-ready solutions, especially 2025 to 2030, you'll want both intelligence and immersive real-time interface. From a competitive vantage, companies that can deploy immersive intelligent experiences on device or hybrid will be ahead of those reliant solely on cloud LLM plus standard UI. For me, AI consultant advising a client in retail slash restaurant slash POS space, or metaverse training, digital twin, etc., I can propose an architecture. Open model scaling for logic, edge slash low power, hardware plus AR slash VR front end for experience. This is a differentiator. 4. Business case slash risk considerations. Upsides. Faster time to value. With open models and scalable hardware, you're not starting from scratch. Major components exist. Lower recurring cost. Once infrastructure is in place, variable cost per inference slash deployment can be lower. Intellectual property. Owning your model fine-tuning, your hardware stack, your immersive experience means you build IP rather than rent it. Flexibility. You can pivot features, tune models, adapt to new data slash customers without waiting on third-party. Edge slash ambient computing future. As devices get smarter and more ubiquitous, AR glasses, mobile XR. The ability to deploy low power makes you ready for that wave. Risks. Upfront investment. Need hardware, model fine-tuning expertise, efficient inference pipelines. Model maintenance. LLMs evolve rapidly. You must keep up. I already believe models get obsolete every 6 months. Edge hardware complexity. Designing slash optimizing for low-power chips is non-trivial. Performance slash thermal trade-offs matter. Safety slash compliance. Using large models and immersive interfaces may raise privacy, data security, accessibility issues. Ecosystem risk. The metaverse hype cycle may overhang. Adoption may be slower than expected and hardware standards may shift. 5. Specific scenarios where this is needed. A retail slash restaurant POS company might offer an AR-enabled staff training module. Managers put on AR glasses, simulate real-life interactions with intelligent virtual staff slash avatars powered by your fine-tuned LLM. The system runs on a low-power, wearable device, so it's deployable widely. A cloud consulting firm like Thor Tech Solutions could pitch digital twin environments for clients, replicate a manufacturing line in VR, integrate an AI agent, LLM, that monitors, explains, or suggests improvements on devices or edge nodes that don't require full data center resources. An AI consultancy building a metaverse readiness platform. The stack is open LLM plus AR slash VR plus efficient chips so that many small slash medium businesses, not just big tech, can deploy immersive, intelligent experiences.